Okay. All right, 6 p.m. Welcome to class, everybody. Seems like it's been a long time since we last saw each other. It's almost a little weird that it's only once a week, but it's great to see you all back. Good to see you again. Today we're going over the second part of the lab, essentially last time. So if you recall, we were doing lab 1, which was a simple exercise, simple in structured text and in ladder logic. So we started off with structured text last time. Some of you guys excelled a lot in that, and others are still learning it. So we still have some more time for that. But we are also going to be learning ladder logic today. So you guys have done it before. Again, great. You'll probably fly right through it. It's a simple matter of understanding the interface, getting comfortable with it, and knowing how to work the simple things. After I give a small lecture, hopefully I won't take too much of your time. We'll get you guys, your legs under you in terms of being able to do simple tasks. I'll let you loose for simple examples, practice working on the software, work on the lab 1 last time. I anticipate that a lot of today will be finishing lab 1 as well as, getting to grips with structured text and ladder logic. The goal of today, if possible, will be to kind of be comfortable with those two things where you guys can kind of understand, how to debug things using the live debug tool, how to download code, and the interface is starting to look more familiar too, right? As usual, if you have any questions, forgot where something is, how to connect to the device, let me know, all right? It can be a little complicated and it's a messy interface. If you lose a window or something and you're struggling, just call me over, I'll be happy to help. Otherwise, I'll just take attendance, as always, and we'll get right into it. Any questions? Good to go? All right, so starting off with Rogelio. No Rogelio, absence. Gabrielle. Here. Thank you. Peter. Thank you. John Eric. Not here. Connor. Here. Thank you. Danielle. Daniel, sorry. Philippe. Here. Thank you. Roberto. Here. Thank you. Bobby. Nope. All right, maybe those guys will trickle in later. Trying to leave them in the dust too much, but we will go over the basics. All right, so go ahead and open up the program. You can make a new program. We're just going to kind of mess around with Scratchpad style. You don't have to save it. It's not important that you turn it into me or anything like that. It's just, if you want to mess around with it, click on buttons while I'm talking. That's fine. The goal is to understand how to work with ladder logic programs. All right, so I'm going to pull it up as well. I'll go to the Arduino PLC IDE. Oh, just a note, I'm going to write this on the board so I don't forget. There is actually a class after us in this class, so when we're done today, I'll remind you later, please unwire and stow away your PLCs. So there's some plastic boxes up here. You can toss the cardboard packaging, whatever, but I would like everything to kind of go in those boxes and be nicely on the station for people who come after you. I never told you guys to do that, so no worries, it's not a big deal, but just please keep that in mind. I'll remind you later. In any case, please open a new project, and then we're going to create a new program within that new project, right, by right-clicking on the top of the project tree. You're going to add a LD ladder diagram file. All right, so new project, call it as-div for me. Eventually, we're going to have to click the compile, but don't do it yet. If you do, it'll hijack your window for a few minutes, okay? So what we're going to do is we're going to right-click, we're going to go add, we're going to go new program, okay? We want ladder diagram for this particular programming language as opposed to structured text, right, which is what we used before. Again, very important that we assign it to the fast task group so it will actually run. If you misclick and put it on the slow or the background task, it'll just run slower. But we wanted the fast task group, and we'll call it LD learning. You can call it whatever you want. Okay, it's just, for us humans. Okay. I want to close those two windows because they're not really helpful. In doing so, it will expand out. My display is really low resolution compared to you guys, so you should have a little more breathing room. But this is the canvas, blank canvas, right, that we're going to put our code on. the way that we add elements to this canvas is very similar to how we use things in structured text. Okay, we tell the program where our sensors are hooked up, right? I1 or I5 or I8, okay, which relay to output things on. So just like before, we're clicking over from the project tab to the resources tab, okay? And we're going to create a couple of resources. All right, what we're going to do now is we're going to go to our button inputs. Remember, this is the user button, the physical button that's on the device, okay? We're going to call it button 1. And you can call it whatever you want. It just has to be exactly that, whatever you want every time, okay? Very important, spelling is the same. What we're going to do, we're going to do an output. We're going to go to our LED outputs, okay? We're going to do green, let's say. We're going to call it LED-G, okay? So now, whenever I say LED-G on an element, it will turn on or off that green LED, right? We're referring to that element, whatever that happens to be. Going back to our ladder diagram, this is our logic, all right? Literally the program that says when this thing happens, this other thing should happen, okay? The way that we actually should kind of cognitively think about this, you know, the cheat sheet in our heads, okay, is that these are called contacts. Right here. Okay, so you can imagine like they're actually two pieces of metal, whatever, that could like come together, or if you put your fingers here, you would bridge the electricity that would cause it to jump here. Okay, if you can imagine this is like a powered rail. Okay, so if you were to press this button, the power could continue on down the rail. Okay. And here it would power whatever this element is, okay, a motor or a pump or a coil, you know, whatever your thing that is being energized by turning on this switch goes into here. So you guys see how there's kind of like this flow from the left through these elements, through this element, and back here, which would kind of be like our ground, right? Okay. So here we are going to add these two elements. So they are here by default. This is kind of like our blank program, okay? We are going to assign it that variable that we talked about before. Okay, so our input is our button, right? Our sensor, it's actually a mechanical sensor. Is there pressure on this button or not? Okay. We're gonna go to the name. I just click these three dots over here. And you could either, if you remembered the variable name, like I just said, oh, sorry, what's up?
Yes, I'm missing the LD learning.
Sorry?
I don't have the LD learning tab. How do I get that?
Oh, so go to project. And then right click, add, new program. And name, LD learning.
And language.
Yes, correct. And then make sure you assign it to the fast task group. And you'll be more or less caught. All right, so again, if I just am really good at my job, I could just throw in LED-G, and that would reference that variable right away. We just make that association. Or if I have, you know, a bunch of variables and I'm starting to forget them, you could just pick them out of the list, right? It'll auto-populate all of your elements, your input and output elements that you configured in our GUI, our GUI on the left. 3 dots right there. Oh yes, double-clicking the contact, that's right. Yeah. All right, so for example, there is always that main variable, or that main program, right? That's just calling a variable count, and it's incrementing it. It's calling count equals count plus 1. So we could assign, you know, the count variable. It's in this list to pick. It wouldn't really make sense, but we're going to assign it the LED-G association, the variable right there, okay? So now, this element literally is this output, or sorry, this input, right, our button input, okay? Oh no, I did it wrong, I'm sorry. I'm misleading you guys. This should be our button. This is our input, this is our contact. So this should be button 1. I would have complained if we tried to compile it, but we didn't actually do it yet. All right, so that makes more sense. It's our input, right, on the left side. Always go inputs on the left, outputs on the right, contacts and coils. Okay? Good vocabulary to refresh on. Here is where we put our LED, LEDG, or you can pick it out of the list. Okay, so now, again, what we can simulate in our heads here is if we were to press this button, we would bridge the electricity from this side over to this side and turn on this element, okay, which would be our green LED. Okay? So, what I would like you guys to do is make this program if you haven't already and go ahead and compile it. Okay, that's going to take a couple minutes. Remember the first time you compile a program, it takes a little bit?
You select the button one for this one? Or?
Yes. So that, again, is in the button inputs on the left here, and I typed in and called it button 1. Again, just for the sake of argument, driving home what variables are, you can put in any tokens, right? It's just a series of hex characters that it compares and makes sure is the same when we're talking about computer world. So if I call this jazz and my input is jazz, those elements make sense, right? The jazz variable goes to the jazz button. Okay, but human readable is always better, so I'm going to keep things simple. This is just button 1. Okay, could be onboard button, right? Native button, whatever. Good stuff. Any other questions? All right, so go ahead and compile. Once you are compiled and have a similar program to what you're seeing up here, I'll help you guys if you're lagging behind or need a little help. Once you're done compiling, make sure you connect to it just like we did before by going to online, setup communication, properties, and setting the correct COM port, right? COM 8 for me. Oh, I forgot that we might actually fix this. I might be able to compile up here. So I'm going to compile, see what happens. I might be able to follow along. That'd be cool. The last 2 times I taught this, I wasn't actually able to demonstrate up here. I had to kind of climb it. So we'll see. Fingers crossed. Anyway, while I talk about that, we'll keep going over theory a little bit. So remember when I said that ladder diagram is kind of like simulating rails, right? Like kind of physical elements that you're turning switches on and coils are firing as a result. We can also enable relay logic. Okay, so if you guys didn't know this, it's actually a super cool bit of history.
Yeah, I actually need a PLC. I don't have one.
Yes, you do. It's right there.
To disconnect from all this.
Yeah. You can leave it, actually. It's fine. You can leave the wiring on there. And then you see the USB, right? I don't know if it's plugged in. It looks like you're missing the blue cable. Right by, back there? The blue and white cable? Yeah. There you go. Gotcha. So there you go.
I have a question.
Yeah.
For the compiling, do you have to do that for every program, every project, or just once you open the software?
Yeah, so that's a good question. The way that it works is that on a brand new project, there's a lot of things that it has to set up. That's why the compilation process takes a while. And then every new change you do have to recompile, but it doesn't touch every file. There's a lot of files that are solved already, and so it tends to take as long. But you do have to do it every time you change any code. And so even when you press this button, for example, that just sends it straight to the PLC, it actually compiles it first and then sends it, just kind of like silently.
But when it takes a long time, it's only when you start a new project?
I believe so, yes. I believe so. It might be every time you start up the program versus making a new project or new program, right? It might be a new program, it might be a new project, it might be starting up the program. I'm not quite sure. Yeah, usually it's like when you did get out of the way, when you first sit down, you usually don't have to deal with it again. Okay, so relay logic. Historical coolness, right? So early computers were made by wiring relays together. Okay, they did math, adding and subtracting bits, zeros and ones, by literally having some relays, right, like little mechanical boxes, wired in clever ways into other relays, so as to make mathematical operations, right? Like simple calculators, you can store data, right? Mechanical computers, okay? So the logic, though, is literally in like, a relay has 3 terminals, a common terminal, a normally open terminal, and a normally closed terminal. Not new terminology, right? Normally open and normally closed relays. Okay? So by using these normally open and normally closed and wiring them in clever ways, you can make AND gates, OR gates, and then from those logical, simple constructs make computers, right? You can build up logic from there. All this said is that the early computers that solved the tasks that we're solving today with PLCs used these relay computers, right? Like people way smarter than us would have to sit down for months and really kind of churn out this wiring to make these computers. Nowadays, we can wire them arbitrarily using ladder diagrams. Okay, the logic is still in the wiring, but we can add new elements simply by clicking on them and saying new contact, right? Okay, so the way that the logic here is that when we add elements like this, it breaks the line. Okay, so for example, in the case of if this was a motor, okay, and this was a switch, okay, if I press this switch, and this was also a switch, nothing would happen unless I also press this switch, right? We call this an AND logic, or an AND gate, right? Tons of stuff that is very useful in the practical world is a simple AND gate. Okay, do you guys ever heard of a safety interlock? Right, maybe 2 buttons on opposite sides of the room. It's a simple AND gate, but it's very important and very prevalent in the industry. Okay, so this is how we can make ANDs. Okay, you can add any number of contacts in order to create the logic that you want. Okay, for example, say this green LED was only on if everything was okay. If we didn't have overpressure, right, if our temperature was okay, right, if all of those elements were switched on saying that they're okay, our green light will be okay. Okay, that's one example of how we use AND logic in the okay. The partner to AND is OR. You guys have probably looked or heard of OR logic before. It's essentially if we press this switch or both, doesn't really matter, this motor would turn on, it doesn't care. Okay. This is done by adding contacts in parallel. Okay, you drop it below, but both of their outputs are fused at this node. Okay, so we can see that, again, if we're carrying, again, pretending that this rail is energized and this is our ground, if we bridge this contact, that will allow electricity to flow. If we bridge this contact, that will also allow electricity to flow. If we bridge both contracts, that's just as well electricity is still flowing. Okay? If we want to really care if both of these are pressed and make sure that if only one or the other is pressed, okay, that is a exclusive OR. Okay? So these are the logical building blocks that we can use in ladder logic and ladder diagram. The puzzle, the fun, if you will, comes from taking a paragraph of text that I give you or your boss gives you, implement this thing, solve this problem, fix this system, and making the ladder logic that directly implements the solution, right? So if you say, when this thing happens, this other thing happens, you can implement that in one rung of your ladder. Okay, another vocabulary term, these are called rungs of a ladder. The reason that it's called a ladder is because as we add new networks down here, we add more rungs, okay? So each of these rungs could kind of be like its own mini program, okay? So for example, this first one that I was talking about, like the status LED, this rung cares about whether the status LED turns on. You might have another rung that cares if a motor turns on. You might have another rung that cares if a fan turns on, right? You might have another one that has communication on it, whatever, okay? This is the parallelization in our program and kind of where a lot of the power comes from. You really have the choice of creating one massive network in one rung, right? You could like really go ham on like there's ways to mathematically simplify logic into crazy like minimum gates and stuff if you want to do it that way. Take like 1 or 2 rungs. Or you could take 20 rungs, make it really simple, right? Like 1 or 2 elements in each, and as long as the logic plays nice, it does what it needs to do, that's just fine. Okay. To that end, the way that ladder logic diagrams work, right, the way that they function in real time is kind of similar to structured text, okay? And then it goes from the top rung to the bottom rung, it evaluates it, and then sees what comes out at the end, okay? So if you set a value to 1 on the first rung, but then on the last rung you set that value to 0, it's going to come out as 0, all right? The 1 will be overwritten, okay? So you got to keep that in mind as we're going through here, because another thing that I haven't talked about, and I'll throw a twist in here, is that you can make these negative contacts. Okay? But a negative contact, or a normally closed contact, has a cross in it, like this. Okay? This means that by default, the switch is closed, and pressing it opens it. Okay? In this situation where we have a normally closed contact attached to an LED coil, like that, okay? This LED will always be shining. If no finger was pressing this button, it would be on by default, okay? Though another way to think about this is that these contacts, when we negate them, outputs a logic 1 by default, okay? All right, here's the tricky part. Make sure you guys stay with me. I'm going to lose you. I almost guarantee it. So just, if you have questions, let me know. Negated outputs work a little bit differently, okay? The way that I like to think about it is that normally closed outputs like that respond to logic low, okay? Where if they see a 0 coming in, that this button is not pushed, this element will turn on, okay? It's simple, but it's a little brain twisty, okay? Contacts are quite easy in just that it's kind of like the opposite state by default, but contacts respond to the opposite state by default, okay? So for example, if you had a sensor that you wanted a motor to turn on, okay, when that sensor is outputting low, okay, say a tank needs to be filled, and we have a sensor that's monitoring, that tank, and if it's empty, it's 0, and then we need to turn the motor on, okay? The ladder logic for that would be this, okay? So that when the sensor is not, when the pool is not filled, if we have a sensor that's up here, right, monitoring to make sure that we aren't overflowing, okay? The water's all the way down here. This sensor reports 0. When the water's up here, this sensor reports 1. Okay, you guys with me so far? In that case, we would want this network so that when this is showing 0, our motor turns on, and when it's showing 1, our motor turns off, or our pump turns off. Okay, with me so far? Any questions? Okay. One more bit of theory. I'm probably going to have a few more one things, but I'm just going to keep saying it as it applies. Is truth tables. Okay. A truth table, if you have never gone through, doing this kind of logic before, and, or, or, and, that kind of thing, truth tables are great because it really cuts through a lot of the noise. Okay, it's great practice that whenever I give you guys one of those examples or those problems that it's like a whole paragraph asking you to do something, that you boil it down to a truth table. Okay, I'm not going to tell you to do that. No one in your job is going to tell you to do that. This is your education telling you that this is the way to go. Okay, so we have inputs on the left and outputs on the right. Okay, the whole point is to distill it down into desired states. When this input is this, this output should be this. Okay, and then you just do that for each of your elements. Okay, so if you have like a button and a sensor, okay, those would be like 2 elements. Okay, and then say you have like 2 outputs, maybe like a fan and a pump. Okay, it can be whatever, the situation doesn't really matter. What I'm trying to show here is, for example, if sensor 1, when that's 0, and sensor 2 is 1, we want our fan to kick in and our pump to turn off. So our fan would be 1, and our pump would be 0. Okay? And then you go down the next line. So this would be one situation. Okay? This comes up in a later exercise when we're going to simulate making a car wash. Okay? For example, we have wash settings, okay? So if they ask for a deluxe wash, if the deluxe wash switches up, you want to run the fan and the soap and the heater, right? If they don't pay for that, you run other things, okay? This is the essence of the truth table. So each one of those situations becomes one of these elements in this row, okay? Each row becomes a ladder or a rung in your ladder, theoretically, okay? It doesn't have to be one-to-one, but it's a guide for you to, again, cut through the noise. What is expected of you? What should the program be doing? And a rubric to test, right? So the really cool thing, let me see if I can actually connect. Hold on. Error. Hold on. Let me see if I can actually demonstrate for you guys. If you worked through it before, you might have seen it. Great. Okay. Give me 1 second. I'm going to simplify this back down to what I had before. Okay. All right, so again, just to drive the point home, I don't have to click compile anymore. If you press this button after changing something, it will compile it for you and then upload. So you don't have to press compile first. You can if it makes you feel better, but it's a waste of click. All right. Always click yes on that prompt. We don't care about cold reboots. Nice. Okay, so this is the power of live debug mode. Okay, so when I press this button and I have just attached or programmed this device, when I push this button, you can see it light up on this network. Okay, you see how it's like I'm bridging it or I'm turning on that button. Okay, so again, as you guys are evaluating, does this program do what I think it should do, you will actually be able to see the ones and zeros turn on in your ladder, in your rung. Okay, and then you can compare it to your truth table. Is my logic working? When I put the inputs like so, again, we're working with simulators, so you can toggle the things on to where they need to be. In that situation, are my outputs setting themselves to what they need to be, right? Is my logic doing what it needs to do? And if not, why not? You can start to trace back and change elements and things like that. Yeah?
Do you mind showing me your programmable inputs?
Sure.
I think I labeled them correctly.
So that's not set, it's only the button input. The programmable inputs, these guys would be for if we had like an external button for a switch that we were wiring into the top.
Okay. I don't think I assigned a variable in the button because that's what I was turning on.
Gotcha. Yeah, it'll yell at you just like before. Like for if I misspelled this or if I accidentally called this button 2 and I went to compile. What's happening? Oh, I'm in debug mode, right? All right, and I went to compile. It would be fine. Why is it fine? Is it because it's not saved?
Reload it, does it work?
If I reload, like, push it back? Oh, well. It will usually complain. All right, the point of this is that you will see some sort of output that is preventing you from compiling, and it'll say, like, variables missing, or you misspelled something, or, you used a capital when you shouldn't have, whatever. Things like that. Yeah.
If I've already compiled and connected, it says it's code in the bottom right. Why would that be?
If you compiled and connected and uploaded, you press this button, the upload button, right here.
I did not do that.
Okay, that might be it. Yeah, so that's the one that actually pushes code to the device.
Got it.
Cool. Any other questions?
So is the user button always tied to a specific variable, or?
If you set it to be so, right? It could be blank, and then it wouldn't be set to anything.
Okay.
It comes default blank. We just called it button 1 or button 2.
So, if we don't set a variable, we just use it as user, call it user, or how do we use it then?
You can call it literally whatever you want.
No, right, but if I don't set a variable,
Then you can't use it.
you can't use it.
Yeah, you have to refer to it somehow. Yeah, it's like you have to know someone's name to tell them to do something. Kind of like that. Any other questions? Okay, do we feel like we kind of understand structured text and ladder logic a little bit? All right, so let's do 15 minutes of making some sample programs. All right, so don't worry about wiring, don't worry about the switchboard just yet, but use this button, use the onboard LEDs, mess around with negating the inputs and the outputs. All right, just play around with it for a few minutes, and then we'll go on with the lab. Okay. Do you have any questions? Let me know. If you're struggling, let me know. But let's get into the inputs.
That breaker works.
It does. I'm not sure if it's connected to your station, but it does work.